Hello all, my name is Augie, and my group and I decided to create our Shiny app based on the old Chinese card game called 24, in which you draw four cards from a deck, and attempt to calculate the value 24 using basic arithmetic. So for instance, if we drew the cards 6, 4, 1, and 1, we know that 6 times 4 is 24, times 1 is 24, times 1 is 24. However, there are many different methods of using these four cards to solve 24, and we list all of the unique methods in doing so. Um, so this Game 24 solver allows the user to input four different cards and observe the different amount of methods and the exact methods in calculating 24. So we can choose any cards between 1 and 13, where a 1 corresponds to an ace and a 13 corresponds to a king, and calculate the different ways of calculating 24. We can also set the target number to anything between 20 and 50. So for instance, 32. And we see that using these four cards, we cannot get 32. Let's try here. And we can get four methods for solving 32 based on 3, 11, 9, and 6. We can also choose the different types of operations that we would like to use in order to calculate our target value. So for instance, if we choose 24 and we only use addition and division, we set our different cards to 6, 4, 1, 1. We see that there are only now 10 methods to calculate 24 using exclusively addition and division. Moving on to the classic Game 24 player, this tab provides four random cards and allows us to calculate 24 before showing the results. So we have 5, 10, 13, and 12. Now, off the top of my head, I can see that 13 minus 10 is 3, 5 minus 3 is 2, 2 times 12 is 24. So now I'd like to see all the different methods. And we see that there are 5. We can play again. And off the top of my head, I do not think that I can solve 24, so let's see all the different methods. And my intuition was correct, you cannot get 24 based on these four cards. So as we began to write this app and our package based on this game, the question came up as to why the game has always been calculating the number 24 as opposed to some other arbitrary number. And we can see using many iterations of random cards between 1 and 13 that 24 always had the highest probability of being able to be calculated. So for instance, if we compare 24 to 25, we see that the probability of being able to calculate 24 is higher for every single respective card as opposed to 25. This means that where one of the cards, at least one of the cards is a 1, at least one of the cards is a 2, and so on and so forth. We have different plots and visualizations of showing this idea. We can also change the target number to compare to the probability of being able to calculate 24. So here we see that the total probability of calculating 24 is 52 as opposed to the total probability of being able to calculate 26, which is 48. So this kind of answered the question as to why the game is 24. Now, moving on, this kind of leads us into our final tab, which is being able to check up to 5 cards if we can calculate 24. So it's pretty trivial to check 4 cards because our app already gives us all the different methods for being able to calculate whether or not we can calculate 24 based on 4 cards. However, we'll give it a go right now. And we know 5 plus 3 is 8, times 3 is 24, times 1 is 24. So this output should be that we can get 24. And that is correct. There is at least one way to get 24. And now we can see that if there are 5 cards, if there is a way to get 24. So now we can input some arbitrary values to test. And notice that the test 5 inputs may take about 10 seconds or so we might have to wait a bit. So it's still going, but I'm still here. Um, yeah, the reason that this takes a while is that there are exponentially more methods that we have to try in a relatively brute force manner in order to decide whether or not we can get 24. So it's still going. And we see that there is at least one way to get 24 based on these 5 cards. So thank you so much for watching our video. We had a lot of fun creating this app and we learned a lot. It's been a fun course. Thank you.